There you go. Okay. So I'm hoping you remember your limits, at least a little bit. So the questions for 5.6, it's called indeterminate forms. And this is the way you pronounce this is L'Hopital. I'm sure I'm also butchering it, but it's a French guy's last name, whatever, right? So his technique was basically when you have a form that's indeterminate, meaning 0 over 0 or infinity over infinity, that means you can't take the limit. So use his technique to simplify it and get it into a form where you can take the limit. So L'Hopital basically says take the derivative at the top, the numerator, and the denominator as two separate things, and then try to plug in a limit again. Because right now, if you plug in 9, you agree that you get a 0 down here, right? You see the problem?
Yes, it'll be undefined.
Yeah, and then if you plug in 9 up here, you will also get a 0. I mean, I know that might not be obvious, but when that happens and you have 0 over 0, you can use L'Hopital to help you out. But we first have to confirm, is it 0 over 0? Okay. So let's start on that idea real quick, and let me write those ideas down. I think I should. Okay. Got to clean my other spiral, use my old one, a little beat up. So this is 5.6, I believe we said,
right? Just to clarify, because my computer was kind of messing up, you said the test isn't until the 15th, right?
Yeah, you take it whenever you want, but the latest would be the 15th of Monday.
Okay, thank you.
Indeterminate form and L'Hopital. I used to call it El Hospital, but I don't think that's right. Anyway, so indeterminate form means, let me phrase this better. So in order to use L'Hopital, you must have an indeterminate form. Okay. Indeterminate form means you take a limit or 0 over 0 when taking a limit. So this is indeterminate. Just put it in plain English here. Indeterminate form. This stuff, okay? So whenever we have this, then we do L'Hopital. I'm going to show the notation and the steps you're doing. So, okay. Let me write down the question. Okay. All right, so here it says evaluate the limit using L'Hopital if necessary. So sometimes you can just plug it in and you're done. It may not be necessary. That's example 1. Problem. Evaluate the limit. Okay, so the limit as x approaches 9. X squared minus 7x minus 18 over x minus 9. Okay, let's switch back here. Okay, so first thing we should do is just try factoring first. Does the top part factor next one?
Yes.
What does it factor into?
-9 and +2.
Yeah, that's right. +2. So in this guy, it appears that I could use algebra to take the limit. Right? You see how I could technically cancel this? Technically. But we're not going to do that because this is a new technique. But the idea is if I try to take the limit, right, I get 0 over 0. So since I have an indeterminate form, then we can use L'Hopital. Okay. So here we go. So when you use L'Hopital, all you got to do, so I'm going to write the question right one more time. I'm going to write this notation so I know that we use L'Hopital. So I'm just going to put a L quote H so we know that we did it. Okay. So what is the derivative of the top? All right, let's do it separately.
2x minus 7.
Yeah, 2x minus 7, right? Derivative at the bottom. It's just 1, right?
Yeah.
So now take the limit. We get, let me show this stuff here. You get 2 times 9 minus 7, which is 11, right? Do you see the idea of L'Hopital, right? We use it when we have something like this, or infinity over infinity. Then you just do derivative at the top, derivative at the bottom, and you plug in your limit. Take the limit. That's it. And if you were to use the other technique that we learned in chapter 2 by removing the discontinuity, remember how we would cancel this? You plugged in 9 here, you would have got 11 anyway, right? So either way, but again, we're trying to learn a new technique here. Any questions on this problem? Okay, let's do another one. Okay. You guys cool on this page? Turn the page. So not too bad, right? So these questions, you're gonna look at them and say, okay, well, do I have indeterminate? This one's indeterminate. This is indeterminate. Let's see, let's do, I don't know, something that looks difficult. The sine thing looks weird. Let's try that one. This is a chain rule. Do you guys see how to do this one?
Yeah, I think that one you just use the chain rule would be an outside would be the square root, and then the 4 minus x squared would be inside, and then you
Yeah.
just okay. Yeah, that one doesn't look too hard then.
Okay, let's try the sign, I guess, and then I'll pick another one. Okay, let me write this down. Example 2. Problem 5. I did not switch the sharing. Dang it. Really, I can't. Sorry, let me leave this on there while I write it down. Okay, evaluate the limit. Sine 2x over sine 5x. All right. So if you plug in 0, what is sine of 0? If I take the limit, I get sine of 0 over sine of 0, right? Which is on the unit circle.
Is 0?
Yeah, 0 over 0. So both signs are 0, so we have an issue. We have indeterminate form. So that means we should do L'Hopital. So what we got to do is take the derivative of the top and the bottom, and then take the limit and see if it's okay. And if it's not okay, you can technically do another L'Hopital. So here's the L'Hopital step, so you can see. Derivative of the top is going to be a chain rule, right? What is the derivative of sine?
Cosine.
Yeah, so it's going to be cosine of the inside, and then you do times the derivative, right? Times the derivative of the 2x. I guess I'll do in a later step. Derivative of sine 5x will be the same, right? Just for the 5x. Okay, so that will be the limit of cosine 2x. Derivative of 2x is just a 2, correct? I'm going to put a 2 over here. 2 cosine. Derivative of 5x is 5, so that's going to be a 5 cosine 5x. So take your limit. You will get 2/5, right? Technically, or if you prefer, 2 cosine of 0 over cosine of 0. What is cosine of 0?
Isn't it 1, I think?
Yeah, it's going to be 1 on this unit circle. So that'll be 2/5 times 1 over 1. Any questions on the derivative or the general idea? All right, maybe 1 second. Let me pick another one then. All right. So far, it doesn't seem too difficult, right? At least I hope so. Okay. And let's do, I guess. I think 6 and 7, and then maybe we could start reviewing or doing some homework. This isn't too bad.
For 6, is it that same rule of like the exponents? Like if you have 2 of the same, like it just equals that. Like it'd be like 1/1, but it actually never mind. I don't know what I'm talking about. Never mind.
Number 6, or no, with the 4/3, right?
Yeah, I thought like last time we were like talking about it, we learned about the
Mhm.
power rule. Like if there's a higher one on top, and then if it's like one on the bottom, then it'd like equal infinity or whatever. But since they're equal, is that just why it's 4/3? Because it's just they use the power rule. Well, like not the power rule, but because those powers are equal, it just makes it 4/3.
Yeah, pretty much. That idea is you can still apply that idea, but if we didn't, you would use L'Hopital until you have 4/3 left. So either way, so you can do it 2 different ways. You can use that as that, since the degrees are the same, right? That idea from chapter 2, that they'll basically cancel each other out and overpower each other. So these powers are the biggest.
Yeah.
So yeah, you're right. We could do that. All right, let's see here. All right, let's do just to show you the other way of doing that. Let's go ahead and do problem 6. Even though we can kind of tell without this technique, because it won't always be that straight up. Like for example, if x is going to 0, that idea would no longer apply, right?
Yeah, I think it's only for infinity, right?
Yeah, exactly. So let's change it to 0 just for fun. I'm sure you guys do these problems for fun, right? On the board. All right, x goes to 0. Go ahead and change it up. 4x squared. What's up, man?
Are you? I can't see what you're writing. I don't know if your
I'm
screen's
writing the
frozen.
question down. Real
Oh,
quick.
okay. Sorry, my bad.
Yeah. If you're following along, feel free to write it down as well, and I'll switch over. There you go. Yeah, I found a workaround for the issue I was having in the classroom. So I'm sharing the program that's viewing through the camera instead of using Zoom to look through the camera. I think it just messes up. Anyway, that's who cares, right? It's the issue I'm having. But x goes to 0. You agree that this limit would be, let's make it actually 1 second, changing this up. No, it doesn't work. Not with this question, at least. We'll leave it as infinity. Okay, so right now we're gonna end up with this indeterminate form. So if we do L'Hopital, that means you take the derivative of the top and the bottom. So this will be simply 8x, right? Plus 7, 6x plus 0. But still technically infinity over infinity. So we'll do another L'Hopital. Derivative of this guy will be 8 over 6, which will be just 8 over 6 since there's no more x's, which is 4 thirds. So you see how you can keep doing L'Hopital over and over again until you're able to take the limit. Does that make sense?
Yeah, we're just trying to get rid of those x's.
Yeah, pretty much. Once the x's are gone, we're not dealing with infinity anymore. Okay.
And we're using the rules from that last homework over these. That's why we're getting the infinity correct. Just want to make sure.
Are you using the what? I'm sorry.
We're using the rules from that last homework when we were talking about like the next chapter of limits, and that's how we're getting our infinities.
Yeah, whenever let me see, what was you mean like last time? Last Wednesday?
Yes.
Yeah, let me see actually. What were we talking about last Wednesday?
I don't know. I just know we talked about another section that was of limits, except they're a little different than the ones that we did before. So I just wanted to make sure these are the same rules that we were doing.
Oh, I see now. Yeah, 4.5 was limits at infinity. So those rules technically still apply.
Yeah. So
But this
these are the
is
rules.
a new technique if you have something like this. So I guess let's pretend you were doing the ones from chapter 4. But if you ran into something like this when you're trying to do the chapter 4 problems, or 0 over 0, like this guy, then you use this section's technique.
Oh.
Okay. That's the only time you use this, is when this pops up.
Yeah, because if it's not 0 over 0, use the other technique, right?
Yeah, you use all the other limit ideas or the stuff we talked about last time, or a couple of sections ago.
So my computer was kind of freezing up, but just to kind of reiterate what she was saying. So basically you use LH basically if it's 0 over 0 or if it's infinity over infinity, just to get rid of the x's pretty much. Do I have that?
That's the only time you're able to use this, yeah. And the idea is you keep taking derivatives until you're able to take the limit. And a lot of times you just need the x's to disappear. Or sometimes in this case, you just needed a function to change it just enough where you're able to plug in 0 or plug in whatever.
Oh, okay.
So it depends. Like there might be a case where something cancels or square root changes a little bit and then you're okay. And in this case, the x's disappear. It depends. But basically, once you do it one time, you check, can I do it now? No. Do another L'Hopital. Can I do it now? Yeah, it looks like we're done. Cool. That's all we're doing. So here, we were able to do it right away after one L'Hopital. So we were finished.
Okay, that makes sense.
All right, any other questions? I think it's pretty much it for that section. It's the same thing over and over again. I don't think it gets much harder. But that is the last section, I think, for test 3. Let me double check. That section's on there. Yeah, there's one L'Hopital problem. And there's one sketching problem. Okay. Yeah, so everything that's since chapter, let me go ahead and write this down. So the first section on here looks like 4.1. 4.1 through today, which was 5.6. Yeah. Okay. You guys have any homework problems you're struggling with? Otherwise, I'll start reviewing for exam 3.
I have a question.
Okay.
Let me pull it up real quick. On 4.6, I believe, I have a question on number 6.
Okay. I did. Which question?
It's number 6.
Number 6. Okay. Okay. This guy, right?
Yeah.
Okay.
Yeah, so I was able to get the X part, but how do we get the Y? Like, I'm so confused.
These Y values here.
Yeah, because like I got the X, but I was just like, what's the Y value?
Oh, okay, that's not too bad. Yeah, you just plug in these numbers into the original. So let me write this down for you. Squared minus, what is yours? Yours is a minus, what is yours on the bottom?
Mine's the same one that you have right here.
Oh, cool.
Yeah.
Okay. All right, so. So to get the other ones, you just have to use the original function to plug in 0. So you get 0 cubed over 0 squared minus 9, which will be 0. So that's how they get that first point for the intercept.
Yeah.
And then you just go there again for the relative minimum. 3 square root 3. You get 3 square root 3 cubed over.
Oh, you're supposed to plug it in. That's how you get the Y. Okay.
Yeah, that's it. So with this one, that'll be what? 3 times 3 times 3. 27, right? Square root 3 times square root 3 is 3 times another one. That's 3 square root 3. This will be 9 times 3 minus 9. Okay. So on the bottom, that will be what? 3 times 9 is minus 9.
27.
Yeah. 18, right?
Yeah.
Okay. Then we have 27. I'm just leave it like this because stuff is going to cancel. It's a 27. There's a 9 in here, right? 9 in there. So you rewrite this over here. How many 9s are in 27?
Oh, 9s. Isn't there a 3?
So I can rewrite it like this. Just so I don't have to do stuff in my head. Right, 2 times 9 is 18, so this will cancel. Looks like this 2 will stay. 3 times 3 is going to be 9, so our answer will be 9 root 3 over 2.
Oh, okay.
So that's what we get here.
Yeah. Thank you.
Yeah. And if you plug in the negative, it's going to be the same thing, but with a minus sign because of the powers. The cube. Does that answer your question, or do you want to plug them all in?
Oh, no, I got it.
You guys have any other questions?
I actually have several, but I mean, I'll take a turn if other
Sure.
people have some questions. So in 4.3, I just need help with number 4 and 5.
4.3.
Yes, sir. I can pull it up if you'd like me to.
Yeah, that's fine.
Okay. My browser is being a bit slow. I don't know why. Oh, it's Edge. That's why. All right, there we go. Nice. Where is it? There it is. Share. Yeah, I think that's the one. All right. You see it?
Yes.
Okay, sweet. Yeah, I just had a question on
This is 4.3, right?
yes, sir.
4.3 problem 4.
Wait a minute.
Okay.
Was this the
So
last
they
one?
give us a function.
Sorry,
On
what?
4, right? Or which one?
4 and 5. I was just trying to make sure like I'm on the right page on my notes.
Okay.
So I was like trying to look at a question. All right, there we go. All right.
Okay. All right, let me switch over.
Okay.
So they want us to find where they're increasing and decreasing, right?
Yes.
The first thing we need is the critical values. And they don't want us to go further than this. Okay, so the derivative will be a negative sign of 4x over 3 times the derivative of the inside, which will be
4/3, right?
Yeah. four.
Yeah.
So then now critical values are in critical numbers. Negative, oops, I put the number in front, 4/3. So set this to 0. So this number won't make a difference. So when is sine 0?
Sine 0, that's 0, I think, right?
Yeah. So critical number is 0 and also 2 pi. That's a 360 or from 0, same spot. Okay. So we have 2 critical numbers. So I'm going to put,
So wait,
Huh?
real quick, why did you use 0? Is it because you set the equation equal to 0 to find the critical number?
yeah, so what makes it 0 is the question.
Oh, okay. All right.
But it looks like I can't go below 0. So I got to test between 0 and 2 pi.
You could use 1, can't you?
Yeah, you can use 1, sure. I was just thinking, I can't check below or above, so it's kind of tripping me out a little bit.
Oh, yeah, to see if it's a decrease or increase.
Mhm. Like I know what can happen in the middle, I suppose. So that makes me think. Oh, shoot. Okay. I think that 4/3. Yeah, I don't think this part's correct. I don't think it's 2 pi. So when the inside is 0, or when the inside is 2 pi, I know for sure this will equal 0, but plugging in 2 pi in there does not change the whole thing into 2 pi. So what I should be asking is what x value will make this 2 pi?
0, I would imagine, right?
No, what would make it equal to 2 pi?
Oh, what would make it okay?
So if I plug in some x right there, how do I make it result as a 2 pi? And if you can't see it, we'll solve for x, right?
Right.
So let's multiply both sides by 3. I guess is this. Divided by 4. I guess is this. So when x is 3 pi halves, that's the other critical number. So now we have points that we can check. So 0 and 3 pi over 2 are my critical numbers.
So, when you set it equal to 2 pi, because that's like the limit, or that's pretty much the range that it wants you to stay within. How come you didn't write down sign next to it as well, since it's being multiplied by it? Or is it just because that's what's within the argument?
Yeah, I guess my thought process was, how do I make this inside part? Because remember, right when we started, we said we know when sine is 0, right? Sine is 0 at 0 and at 2 pi, but this is not a normal sine. The argument has been changed, so now the question is, well, how do I make that argument?
Oh, how do
into
you?
2 pi?
I see. So basically, it's okay. Yeah.
But if I would have used the whole thing, I would have needed to use inverse functions, and I would have got here anyway. But I figured this. I thought maybe this made more sense because I need a 2 pi in there. How do I make that inside 2 pi? Well, you can solve for this and find out that answer. I don't know if that is that weird. Does that make sense?
Kind of, but not kind of. Like, I wouldn't have thought of it that way until you mentioned it. Because the way that I was trying to solve it was, all pretty much like all of the other ones was just set it equal to 0 and solve for x so that I could find my critical numbers.
Mhm.
But I wouldn't have thought of putting it equal to 2 pi since that's one of the other limits because it gives you 2.
Okay,
Because pretty much you're trying to find
well, we can do it the other way if you like.
yeah, whichever way, doesn't matter.
Do you want to do it with inverses or?
No, this is fine. I mean, this seems easier, I think.
Okay, because we can find these, we could find them with inverse functions, right? We could solve this equation like normal and not be weird.
Okay,
Just want
yeah.
to.
Yes, yeah, that would be fine.
Okay, yeah, let's pause this part then. So those are the answers I need to find. So I want to solve this equation now. You agree that the negative 4/3 next doesn't matter.
Right. Because you can just pretty much take it out since it's multiplying.
Yeah, so if we use inverse sine of both sides, like we did back in pre-calc, we're going to get these to cancel, which gives us 4x over 3. This will be equal to 0. So that means that x, when you solve for x, is equal to 0. That only gives you one answer because the inverse function only has a range between negative pi over 2 and pi over 2. So I can't find the other one, but we can use this idea of reference angles to find the solution. So what you can do is subtract from 2 pi. So this will be my first angle. My second angle will be 2 pi minus 0, minus the other angle. This gives me the other one. But I would have to use this one. So it would actually be this. So I end up doing this anyway, but you're using these ideas of inverse angles or inverse functions.
Oh, okay. So basically you're wanting it to equal the limits on both for both of the limits basically.
Yeah, so I guess it might make more sense to say, you know what? Once I cancel it, this on the calculator, this is only going to give me 0. So I'm like, but I know there's another one. So I should set this inside part equal to the other. Like if I go full circle, I'll be 0 here
That makes sense.
on the unit circle. Because this calculator can only give you that one. So anyway, you solve for this and you end up with x equal to 3 pi over 2.
Okay. So those are the critical numbers.
Yeah, so these are the critical ones, and then we start our testing. So let's test on the other side. Okay. Alrighty. What we're doing now, you guys go on that page? So we're testing between 0, 3 pi over 2, and after that. And the function is Derivative of negative 4/3 cosine, right? 4/3.
The derivative is negative 4/3 sine.
So we just plug them in and see what sign they are. So 3
Wait, is
pi
that-
over 2, what's up?
Is that the derivative or is that just the actual function itself?
Oh, yeah, derivative.
Oh, because it's I think it's negative sign.
Oh, is it sign?
Yeah, yeah, there you go. Sorry.
Yeah, we need to use the derivative to test for increasing and decreasing. That's
Okay.
what the first derivative does for us. Tells us about slopes, right? So negative 4/3.
Whoa, how'd you do that? Wait a minute.
What's up?
Oh no, I was wondering how you did that.
The fraction?
Yeah.
I hit alpha and then y equals. And then you get to choose function buttons or fraction
Oh.
buttons.
What the hell? That's cool.
It makes things a little prettier when you're, yeah, complicated stuff.
That's neat.
So I'm gonna plug in, so anything between here and here, I'm gonna choose pi. Yes. Pi is less than 3 pi over 2. We are negative here. Okay. 3 pi over 2, what's a good point after 3 pi over 2? Unless you do.
5 pi over 3.
Okay. Five pi over 3. Well, we can't go beyond 2 pi, right? Just 1 second. Let me check something. 2 pi is 6.28. So I could just pick an easy number like 5, right? It doesn't have to be a fancy pi thing. Here it shows pi as my test point. Over here, I'm going to choose the number 5. Just to be lazy. Because then I can come up here, right, and replace that pi with the 5. So we're negative. Interesting. So they are both negative.
Wait, how does 5 still fall in between 2 pi?
This 2 pi is 6.28.
Oh, okay.
And 3 pi over 2 is 4.7. So it's technically over here somewhere. Right. You can choose any number between 3 pi over 2 and 2 pi. There's an infinite number to choose from, and I chose that guy. 4/3.
What about because I'm looking at the unit circle, what about what the other person said, 5 pi over 3?
Just realize I'm not in radians. Let's see. Redo this one. This one was actually positive. You want to do, which one did you say? 5 pi what?
Yeah, 5 pi over 3.
Okay, we can. I put parentheses 5 pi over 3, I guess, right there. That's my x that's being plugged in. Negative. So that one was negative. So we can say we are decreasing from 0 to, sorry, increasing is that one. 0 to 3 pi over 2. decreasing from 3 pi over 2. The ending was 2 pi, right?
Correct.
So we can say up until 2 pi.
Okay, that makes sense.
Should work.
Let me see. Oh, okay, yeah, that makes sense here. Let me type that in.
Yeah, we can do that 5 on 3 3 even. Okay, 5 on 3.
If I marked my answers wrong.
It did?
Yeah, for increasing from
Yeah, I see.
yes, here. Unless I fat fingered something. Let's see, where's the share option? Oh, right here. And green. That green button right there. Gosh.
All right. Let's see. Increasing derivative. Okay. It looks like you plugged it in, right? I wonder if they want the, well, let's take a look at the graphs first before we start changing anything too drastically. What was the original function?
The original function was a cosine and 4x over 3.
Okay, and we said the points x equals 0 and x equals 3 pi over 2 were critical numbers, right?
Yes.
Okay, so here's 0. Just to mark it for me here, 2 pi's right there. Okay. So ignore the purple line. So the beginning is the blue one, all the way to here, the purple. You have a critical at 0 and 3 pi over 2. But it looks like there's another one here. Interesting. So what happened? I see. Yeah, there's another critical number that we missed. One moment. You said that was number
It's
4.3 number.
Yeah, 4.3, number 4.
Okay. Let me take a, let's take a 10-minute break. I need to go to the restroom and let me think about this.
Okay.
Give me a second. I'll be right back.
Yes, sir.
All right, so derivative of this guy times the second minus 5 plus the second part derivative times the first part. All right. So this derivative will be It's the power rule, right? Times this guy. Derivative of this will be 25x to the fourth plus 4 . All right, so that's the derivative. I mean, technically you can FOIL all this out. That is the first derivative. Any questions on the product rule?
No, it was just more of, I had no idea what to do with the C, but I think you said you just plug it in, right?
Yeah, you just do this. Plug in the 0. So 0 is what's my C. So it'll be 3 times 0 plus 2 times 5 times 0 plus 4 times 0 minus 5.
Oh my gosh, that's all I had to do.
Yeah. Sorry.
No, you're good. Oh my gosh, I feel dumb.
There we go. So that's going to be 0. So then we'll end up with 2 times -5 plus 4. So -6, -10 plus 4, -6. It looks like they didn't even FOIL it in the answer. They just left it like this for a derivative.
And that's just C. Like that's all it is. It's just 6.
Yeah, that's it for number 5. You said, right?
Yeah. All right. Thank you. That makes more sense. Now the other ones make more sense now.
Yeah. So see how they didn't even FOIL anything. They just did it like I did with the formula, and then you plug in 0 and you get this number. Looks like I might have made a mistake on the number, but that's because this would be 6. Okay. But anyway, you said it makes sense though.
Yeah.
Okay. All right, we're just about out of time. I'm going to start office hours a little bit. If you guys want to come in and ask more questions, you're welcome to. Okay. But I need to open it up in case other people are going to come.